This is George. George is this belt grinder that I just made. Before I show you a montage of me making George, which is mostly just grinding and welding, we're just going to talk about George a little bit here. We're going to talk about George performance characteristics. Okay, to start with, George is a 2x72 belt grinder, obviously. This is a 4.25 horsepower DC motor. It came off of a treadmill. 12 and 14/16. And 10/16. Did I say 10/16? Because I meant 9/16, which actually puts the cutting rate at 20/16 per minute. Let's look into some of George's features. Dude, I haven't even... oh, okay, yeah, it was in focus. Okay, nice. Some of the features of George that are really features of any belt grinder. Well, most of the ones you'll see nowadays. George tilts, just like most of them do. Can adjust and remove the tool piece and replace it with whatever you want. You know, you could put in a round wheel in there. It would be pretty easy to do. Table is adjustable in all the dimensions. I'm not going to demonstrate it because it's, you know, not that interesting. I made the mistake of painting this piece, which makes it a lot harder to slide. But there you see. Yeah, and so, you know, those are some features. One of the other things, well, really actually the only thing I think that differentiates this belt grinder. Give me the fucking camera. One thing I noticed with all the belt grinders I've seen, I mean the 2x72s, they call this a flat platen. This is really the only important part of the tool. I mean, yes, the rest of the tool has the function to drive to make the tool work, but this is the work area, this front flat face here. And I noticed that on all the machines, this flat face is like, what, 12 inches? Not even. It's tiny. And then the rest of the machine is super long, and it's just a waste of space. So when I set out to design this machine, this is a 24-inch flat face. So when this thing is on its side, this is 24 inches to work with. You can flatten a 24-inch edge. I've already used it, and what the fuck am I trying to say? It is already come in handy and being useful. This thing it's basically a triangle, which triangles are dope. My design and build philosophy for this project was to do it as cheaply and as easily as possible. All the components are extremely simple to design and build. The whole project is made up of 1/4 inch by 2 inch flat bar, a few pieces of angle iron, a 1/2 inch plate as the base. 2 pieces of 4-inch wide flat bar that form part of the hinge for the rotating mechanism. And the other piece of 4-inch flat bar is the work table, but most of it is just 2-inch flat bar. I've welded it together in several places to form more rigid lengths, especially for this. Oh my, welded it together to place more rigidity. Oh my god. I've welded to give it more rigidity. Fuck. One area I thought I could save a lot of work on was the hinges. All the videos that I've seen of people making these belt grinders, they carve out an arc in the hinges using drills and a file, and I really couldn't understand why. So I designed it just for a pin where you could choose between vertical and horizontal. But in the end, the fit was so good that I didn't really need to install the pins. It just kind of friction fits itself in place. So I just can't understand the point of the arc. I mean, when are you ever going to need to lock the thing in place at an angle like this? And cost breakdown, and I spent this amount of money building this thing. Let's look at where that cost came from. By far the most expensive component of this machine were the wheels. I spent 140 Canadian dollars on those, plus $30 in import fees. So that's $170 for the drive wheels. The motor, this cost $40. I bought it on Facebook Marketplace. $25 were spent on the various bolts and nuts and that juicy nut. The electrical control for the motor is just this SCR motor controller and this rectifier here, which just came into probably $20 for both those included. The only other costs are steel, and I also bought all the steel from Classifieds. I crunched the numbers and I think I spent around $40 for the steel to make this. So that brings the total up to $255 plus $40 is $275 Canadian dollars to make this. Whether or not I think that after doing this, it's worth it. Is it worth it? You can buy these machines from anywhere between about $1,000 all the way up to like $3,000 and $4,000. This one has features that you would find on the more expensive ones. I mean, it certainly has more horsepower, at least on the face of it, than all of them. I haven't seen any grinders that have 4.25 horsepower. The worst case scenario is I save myself about $700. In the best case scenario, I save myself thousands of dollars building this thing. So if I was working a minimum wage job, I would have earned $1,200. Assuming one of the better case scenarios, this venture was actually profitable for me in terms of the value added, especially because I don't have a job. What I'm gonna try doing is using the flywheel that it came with, cutting off the excess and grinding it down so that it fits this bore. I don't have a lathe. If I did, this would be a hell of a lot easier than it's going to be. Damn, this is a good haul. Not so bad. Perfect fit. A little tiny bit of clearance. Slides all the way in. It's so freaking hot. Whoa! So satisfying peeling back this tape, seeing that fresh, clean steel